Okay, so we are starting with 3.1 congruent figures. Okay, now your objective is to understand the concept of congruent figures and also to be able to accurately identify the corresponding parts of the figures using rotation, reflection, and sliding. Not necessarily in that order though. Okay, in general, two figures are congruent if one of them could be placed on top of the other and fit perfectly. In other words, congruent figures have the same size and shape. Okay, now definition here. Congruent triangles are two or more triangles that have all corresponding parts that are congruent. This two-directional symbol means that the statement is reversible for use in proofs. Okay, in other words, it's a definition. Remember, definitions are reversible. The single directional means implies. It's an if-then statement, and it may not be reversible, so be careful with those. Okay, so for congruent triangles, every triangle has 6 parts, 3 angles, and 3 sides. And in congruent triangles, say triangle ABC, and then we would say that it's congruent to FED if angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. Also, that segment AB is congruent to segment FE, segment BC is congruent to segment ED, and that segment CA is congruent to segment DF. Okay, now when showing congruence in triangles, the order is important. Okay, you could not say triangle ABC, this first, second, and third is congruent to EDF, because if you try to arrange them in that order, say matching up E with A, okay, these angles aren't the same, so they're not congruent. Okay, it's not the same triangle anymore. So the order does matter. So make sure that you're lining up the congruent parts with each other. All right. And as a little side note, definition of congruent polygons is that all pairs of corresponding parts are congruent. So, like say squares, there would be 4 sides, 4 angles that were congruent. Okay. And in order to write a lot of these proofs, you're going to want to refresh your memory about the following properties. Hopefully you've learned them before and that will be just a refresher. But the additive addition property, multiplication property, division property, subtraction property, transitive property, and substitution property. At the end, I'm going to tell you where in your book you can find them if you want to kind of go back and see how they apply to this. I'm also going to be making a handout for you guys that you'll be able to have handy. All right, now let's look at transformations by reflection. Okay, reflection is when a geometric figure reflects over a line. For example, if we said triangle KET, oh, can't see it, hold on, there we go. KET is a reflection of KIT over this line here. So this line right here, okay, that's what we're reflecting over. So when I say reflecting over, I mean that that's basically if I took a mirror and held it up there, that it would reflect over that. So angle I reflects onto angle E, angle 1 reflects onto angle 2, angle 3 reflects onto angle 4, segment KI reflects onto segment KE, segment IT reflects onto segment ET, and finally segment KT reflects onto itself. How can we do that? Well, when an angular side is shared by 2 figures, as KT is here, we can say that it's congruent to itself. And this property is called, oddly enough, the reflexive property. So keep that in mind. You're going to use it a lot. Okay, now sometimes there's transformation by sliding. Take, for example, the 2 figures below. See how I slid that in there? Kind of neat, huh? Anyway, PQRST is congruent to VWXYZ. Notice that the P and the V match up. They're the first letters, and so do the subsequent letters. Q and W, R and X, S and Y, T and Z. All right. So this correspondence is apparent if we slide this onto this. Okay. It would match up identically. All these angles would match. All these segments would match. It would be perfect and beautiful. And they would be congruent. Okay. Now let's look at transformations by rotating. So I'm telling you right now, these triangles are congruent. Figure out how they correspond. We can rotate triangle FGH onto LKH. So basically this F would rotate down here to L, G would rotate to K, H would stay where it is because that's where it's rotating about. Okay, angle 1 rotates onto angle 2 at H, and therefore all these corresponding points are also congruent. Okay, so again, that's by rotation. Excuse me. Last couple of things. Properties mentioned in slide 6 can be found in chapters 2.5 to 2.7 in your books. Like I said, I'll also make handouts to help you each learn these. And the reflexive property is a postulate, okay, that is used often in proofs. Often in proofs. So make sure you know it inside and out. Okay, I know I went through that really quick, but this is fairly easy stuff. The next unit might even have to be broken into 2 parts. So anyway, enjoy the easy chapter and prepare yourself for more proofs starting tomorrow. Have a nice night or day.